In example 2, we're told to consider a trial where 12 jurors will be selected across an entire U.S. state where the population is 29.56% black. Given a large enough population, selection without replacement can be considered independent trials. This is an important statement to include so that we do have a scenario that meets the conditions for a binomial experiment. We want to use the binomial distribution to complete the following. In order to save time, I've offline just gone ahead and included the heights of each of these dots so that we have those corresponding probabilities for each outcome. You may want to go ahead and pause and fill those in, but we'll use those values to start calculating probabilities that we have in parts A through F. In part A, we want to find the probability that exactly 4 of the jurors are black. That would be the probability that X is exactly equal to 4, in which case we'd find the 0, 1, 2, 3, 4th dot, and that probability then would be exactly 0.2291. So that's the height of the dot over X equals 4. In part B, we want to find the probability that 5 or fewer of the jurors are black. That would be the probability that X is less than or equal to 5. We could just start with the probability that X is equal to 0 and keep adding as we go. So we would start with 0.0149 plus 0.0751 plus 0.1734 plus 0.2426 plus 0.2291 plus 0.1538, where those are the corresponding heights of the probability of X being exactly equal to 0, 1, 2, 3, 4, and 5. Adding each of those decimal values together then would give us the probability that we're after in part B. In part C, we want to find the probability that fewer than 5 of the jurors are black. We could take a little bit of a shortcut here, and we could start with the probability that we found in part B, which was the probability that X is less than or equal to 5, and we could subtract the probability that X is exactly equal to 5, which would be the same thing as just adding the probability that X is equal to 0, 1, 2, 3, and 4 above. In part D, we want to find the probability that the majority of the jurors are black. Here we have an important statement. Whenever we talk about the idea of majority, this is a statement or a concept that will pop up through another number of topics this semester. That means more than half, or more than 50%. In this case, we have 12 trials, meaning we would need to find the probability that X is greater than 6. If we had exactly 6, that would be half of the jurors, so we need more than 6 to make sure we have a majority. So we would start with the probability that X is equal to 7, which would be 0.0271, and keep going from there for all values higher than that. 0.0071 plus 0.0013 plus 0.0002, and then our last two values look like zeros but really aren't technically. They're just values that once we round to 4 decimal places, round down to 0 rather than rounding up to 0.0001. So they are approximately 0. But these are our values for X being exactly equal to 7, 8, 9, 10, 11, and 12. And again, adding those together would give us that total probability that we're after. We could find the probability that between 1 and 8 of the jurors would be black. This would be the probability that 1 is less than or equal to x, is less than or equal to 8. So we could start off with the probability that x is exactly equal to 1, which would be 0.0751 plus 0.1734 plus 0.2426 plus 0.2291 plus 0.1538 plus 0.0753 plus 0.0271 plus the eighth value, 0.0071. Then we can find the probability that x is 10 or more, or 3 or fewer, which would be finding the probability that x is greater than or equal to 10, or x is less than or equal to 3. And we could find that by starting with the probability that x is exactly equal to 10, 0.0002, plus the probability that x is equal to 11 or 12, which are both approximately 0. And then we could start at the probability that x is exactly 0, 0.0149, and work our way up to 3. So we'd add 0.0751 plus 0.1734 plus 0.2426. Again, all of that work is just to get at this idea that when we're using a binomial distribution, we're looking at individual values and the heights of those points, and then possibly considering multiple outcomes just depending on whatever our probability statement is. So we're looking at those specific heights and adding those together for all of the corresponding probabilities that we're after in our problem.